Hey everybody, this is Miss Darty. I want to show you how to do orbital diagrams of ions, and this is not necessarily different than regular orbital diagrams. It's just that the plus and minus signs might give people trouble, so we will go ahead and do a video over this, and I'll show you how to do these orbital diagrams. So, one of your problems on your homework is sodium with a +1 charge. And if we had neutral sodium, looking on the periodic table, our atomic number is 11 for neutral sodium, but this is sodium with a +1 charge. So, sodium with a +1 charge, that +1 means that we have lost electrons. And we have lost, in the case of sodium +1, we have lost 1 electron. So, sodium +1 has 10 electrons. And the easiest way to do that is you take your atomic number and do the opposite math of the charge. Regardless of what charge you have, you always do the opposite math of the charge. So sodium +1 has 10 electrons, so we're going to go ahead and fill this orbital diagram. We have 1 electron in the 1s, the second electron a down arrow in the 1s. 2s fills the same way. That's 4. 5 comes in as an up arrow in the first box of the 2p. 6 comes in the second box of the 2p. 7 comes in the third box of the 2p. 8, then you get to pair, so 8 comes in as a down arrow in the first box. 9 comes in as a down arrow in the second box, and then you have another down arrow in the third box, making up 10 electrons. And then for your orbital diagram, or your electron configuration, you will have 1s2, 2s2, 2p, and there's a total of 6 electrons in the 2p. Now, another step of your homework is to circle the valence shell and state the number of valence electrons. Now, remember the valence shell, if you fill up a p sublevel, then the valence shell is that p sublevel and the previous s sublevel. Because they both have a coefficient of 2, that means they both are the valence shell. So the 2s and the 2p are make up the valence shell, and our valence electrons in our circle, we have 8 valence electrons. If we were to do another problem, like this, and do, let's say, nitrogen -3, or the nitride ion. Neutral nitrogen has 7 electrons, but nitrogen nitride do the opposite math of the charge, so nitride has gained 3 electrons to the opposite math of the charge. Nitride has 10 valence electrons. So start filling. You have you start filling. You have one up, one down in the 1s, one up, one down in the 2s. The fifth goes as an up arrow in the first box. The 6th goes in as an up arrow in the second box. The 7th goes in as an up arrow in the third box, and then you pair. This is Hund's rule. So a down arrow is 8 in the first box, down arrow in the second box is 9, and a down arrow in the last box is 10. So then the electron configuration for this nitride ion is 1s2, 2s2, 2p6, and the valence shell, we filled up a p sublevel again, so that includes, the valence shell includes the previous s and that p sublevel. So we have the 2s and the 2p as our valence shell, and in that circle we have 8 valence electrons. So those are orbital diagrams of ions. You also, your homework includes you doing exactly what I did. Draw the orbital diagram, write the electron configuration, circle the valence shell, and state the number of valence electrons. Thank you very much for learning with me today. I enjoyed learning with you.